Okay, so you're given this outline of a shape. It's kind of a funky shape, and they want you to rotate it over the y-axis. And so to do that, let me just change my color here. I'm going to go from here to here. There's C prime. I'm going to come back here. I'm going to get this funky rotation there so it looks like a hemisphere on top. And then I'm going to go out another 3 this way. And I'm going to rotate this here. Right there. When I connect this down here, it looks like a cone there. So that's the funny shape I have. And so I've got to label some things. So let's do that. Well, first of all, we know that the radius, whoops, there's the radius of it, there's the radius of the hemisphere. The hemisphere's radius, we'll call that radius of the hemisphere is 3 units. Okay? We also have, I'm going to change the color here, a cone here, and the cone's radius looks like 6. Now the cone also has the height here, the height of the cone looks like it's 1, 2, 3, 4, 5, 6, 7, 8, and you can really check that it's going from 2 to -6, which is 8 units, so it works both ways, counting and that. Okay, so we've got that, and so we really have one other trick though. This is the other trick. This is not on the surface any longer of the hemisphere, and it's also taken away from the larger circle on the base of the cone. So we have to subtract it twice, or we can just call it the lateral surface of a hemisphere. So a hemisphere is normally 3 pi r squared, but we're only going to have 2. So I'm going to change that to, so really our plan is this: the total surface area is going to be the lateral surface of a hemisphere plus the total surface of a cone. Okay, and when we say lateral here, we've already taken off this yellow circle on the bottom for the hemisphere, that not being there, but we haven't taken it off for the cone. So we're going to have to subtract the area of the small circle because it's coming off the cone's total surface area. Okay, so we've got this formula. See if we can fit it all here. So I'm just going to put the dashed lines. Total surface area, hemisphere, the lateral is 2 pi r squared plus, we've got the cone. Okay, we've got the cone, and the cone is pi rl plus pi r squared. And oh, I forgot to put down, this is the hemisphere's radius. This is the cone's, oops, that's the cone's radius. Okay, and then we're going to subtract the small circle, so that would be pi r squared of the hemisphere. That's the radius of the hemisphere. Okay, so we've got all these things kicking around. We're going to have to be careful with it. here's the total surface area. I'm going to try to write all the stuff there. So 2 pi, and then the radius of the hemisphere is 3 squared, plus pi, radius of the cone is 6, times L. Oh, that's a problem here. So we've got, see how we can, here's L right here, the slant height. So we really have Pythagorean theorem. We've got 6, 8, that means this is going to be 10. How do I know? Because 6 squared plus 8 squared equals L squared. And it turns out that becomes 100, which is 10. Or you could use a Pythagorean triple. It's a 3, 4, 5 times 2. So I've got to put that slant height in of 10. Okay. Then I'm going to, so I've got this part done, this part done. I still need to do this right here. So I'm going to add pi, the radius of the cone, and square it. Radius of the cone is 6, and I'm going to square it. Whoops, and I got to subtract, not add, the small circle, the yellow one there. Pi, the radius of the hemisphere is 3 squared. Okay, so there's a lot of, so now you just got to be careful with your calculator, but the rest is just plug and chug. And so when I do that, I'm going to end up with 18 pi for this part here, and then for this is going to be 60 pi, and then I'm going to have this part here 36 pi, and this part here subtract 9 pi. And when you do all that, you get an exact surface area, although it didn't specify, of 105 pi, which is approximately 330 units squared.